Meter bridge. Aim: to find the resistance of the given wire using meter bridge and hence to determine the specific resistance of its material. To verify the laws of combination, both series and parallel, of resistance using meter bridge. Theory: the meter bridge is working under Wheatstone's principle, which states that when no current passes through the galvanometer, that is, when the bridge is balanced, P by Q is equal to R by S. In a meter bridge, an unknown resistance X is connected across the left gap G1 and a resistance box R in the right gap G2. Therefore, the Wheatstone's principle becomes X by R is equal to resistance of AB divided by resistance of CB, where B is a balancing point in the meter bridge wire where the galvanometer shows null deflection. Then X can be calculated using the formula R into L divided by 100 minus L, where L is measured in centimeter. Procedure: make the connections as shown. Connect a battery between the two terminals A and C and a galvanometer between D and a jockey B. A key K is also introduced in the circuit. The unknown resistance X is connected in the gap AB and a suitable resistance R from a resistance box is introduced in the gap CD. Then the jockey is pressed near A and then near C. If the galvanometer deflections are in opposite directions, the connections are correct. A suitable resistance is introduced in the resistance box so that the galvanometer shows zero deflection when the jockey is pressed almost at the middle of the wire AC. Measure the length AB as L1. Now interchange X and R, that is connected X in G2 and R in G1, and again measure the balancing length L2, that is CB on the same side X. Then the unknown resistance can be calculated using the formula X is equal to R into L divided by 100 minus L. Then its resistivity and hence conductivity can be calculated by using the equations ρ is equal to pi r square into X by L and sigma is equal to 1 by ρ respectively. Now connect the two resistance X1 and X2 in series and then connect this combination in the gap AB and repeat the experiment for different values of R. Then calculate the effective resistance XS using the equation XS is equal to X1 plus X2. Now connect the two resistance X1 and X2 in parallel and then connect this combination in the gap AB and repeat the experiment for different values of R. Then calculate the effective resistance XP using the equation XP is equal to X1 X2 divided by X1 plus X2.